Hello, this is Loxa Games, and we are playing Human Resource Machine by the Tomorrow Corporation. And in this episode, we are going to do levels 6 through 12. Does that make sense? Let's go all the way up to 14. I've already tried to record this video a couple of times. It has not worked out yet. Fourth time's the charm. Starting on rainy summer. Grab a new tab. And let's see, for each two things in the inbox, we'll add them together and put the result in the outbox. Inbox. Copy to 0. And it informs us we got a new command. We can add the content of a tile on the floor to whatever value you're holding. So we'll go back to the inbox. Now we're holding the value from the inbox, so we want to add that to the value we placed on the floor, outbox the result, and jump back to the beginning, and let's see how that works. 8, 7, added together is 15. We can see that this is going to work just fine. We see we have some new challenges. We are being evaluated for our size and speed. And we have aced it, so we'll continue to the elevator. And let's go to our 0 exterminator. Oh, he jabbers on, so my performance will be evaluated with extra scrutiny. We're going to send all things that are not 0 to the outbox. And we got a new command. It jumps only if the value you are holding is 0. Alright. So we'll pull something from the inbox. If it's 0, we'll ignore it. If it's not 0, we'll send it straight to the outbox. We'll round it out with a jump. And let's see how that works. 4 is not 0. 0 is 0. So we just throw it away. This is working fine. Throw away the zeros. Toss them. They turn to dust. So we did that in only 4 commands, meeting the size challenge. And we met the speed challenge. So continue to the elevator. And we'll go to the tripler room. So in this room, we need to triple each thing in the inbox and outbox the result. So let's copy our inbox to tile 0 and then add that back to itself a couple times. So we've added inbox to itself 2 extra times. That will give us triple the value. Outbox, round it out with a jump, and let's see how it works. 3 plus 3 plus 3 is 9. Yes. That is working very fine. A nice, elegant solution. We have met the size challenge. And we have met the speed challenge. Continuing to the elevator, where we will check out the Zero Preservation Initiative. Oh my! The Zero Advocacy community felt the previous assignment was not inclusive. Now we want only zeros. We don't care what happens to anything but zeros. Alright. We'll grab from the inbox. And then we're going to use our little jump if zero command to go to the outbox. But if the number's not zero, let's just jump back to the beginning and throw it away. Put a jump at the bottom to round it out. And let's see how our program executes. 0 is 0, so it goes to the outbox. That's not 0. That's not 0. Oh, found a 0. Here we go, running across the floor with all our zeros. How'd we do? We met the size challenge. Oh my, we did not meet the speed challenge. Let's go back and see what we can do about that. We're gonna copy our program, paste it in a new tab, and one thing we can do to make our program execute in fewer steps is just repeat without a jump, because that jump at the bottom takes a command. So everything between the jump we're now doing twice. I think that'll be enough for us to meet the speed challenge. Let's see what the answer is. We used 9 commands now. Oh, nope. Not quite fast enough. We will have to do that one more time. You can see that it did go faster. So now we have 3 times. You know what we could do? We could take these jumps and go on back to the top. That way, the jump way at the bottom will execute even less times. I bet we will find that this is acceptable. And we never got 3 zeros in a row, so we probably didn't have to put that third repeat in there. But we have beat the speed challenge, so we will continue to the elevator and go to floor 10, the Octoplier suite. Alright, for each thing in the inbox, multiply by 8 and put the result in the outbox. Using a bunch of add commands is easy but wasteful. Can you do it using only 3 add commands? Management is watching. From the inbox, we are very familiar with copying to tile 0 and then adding it back to itself. So at this point we have multiplied by 2. Let's take our new number and put it on tile 1 and add that to itself. Ah, now we've multiplied by 4. We'll take our new number, copy to tile 2, add that to itself. Now we have multiplied by 8. That is what we want in our outbox. Round it out with a jump and watch her run. 4, 8, 16. We are getting the answers correct. Getting a good solid multiply by 8. And it even works for 0. So we are golden. And we have met the size challenge and the speed challenge. So we will continue to the elevator. To the sub hallway. Subtraction. Oh my. I never learned that in school. Did you? We got a sub command. That's gonna subtract the contents of a tile on the floor from whatever value you're holding. So we need to subtract the first from the second and put the result in the outbox. Then subtract the second from the first and put that result in the outbox. Okay, good enough. We will copy our value to the 0 tile. Then we'll copy our next value to the 1 tile. So we're holding our second value, and we want to subtract our first value and outbox it. And then we're going to reverse that. Get back our first value. Subtract our second value. Outbox that. And round it out with a jump. So we are having to lay both tiles on the floor to finish this assignment. We got 1. We got -1. We can see how it is working like a charm. Speed this up a little bit. Making her run. We met the size challenge, 10 commands, and the speed challenge, so we will continue to the elevator and go to floor 12, the Tetra compiler. For each thing in the inbox, we're going to multiply by 40 and put the result in the outbox. Alright. Inbox. Copy to 0. We remember from our old program where we multiplied by 8 that by just continuing to put these results into subsequent tiles, we basically exponentially increase our result. So let's lay them all out. And alright, so in our 0 tile, we have our original number. On our 1 tile, it will be multiplied by 2. In our 2 tile, it's been multiplied by 4. Then 8 in the 3 tile, 16 in the 4 tile. And we added the 4 tile to itself, so that is 32. But we need 40. We need to multiply by 40. So we're going to need to add the 3 tile back to that result, because 32 plus 8 is 40. That is the result we want to send to the outbox. And then jump back to the beginning. So let's see. When we start with 4, 4 times 40 is going to be 160. So hopefully we will get that result with our solution. And yes, we got 160. Negative 5 times 40, negative 200. And it's looking good. So we can see this is all working fine. We'll speed that up. And yes, it even works with 0. We met our size challenge. We met our speed challenge, and we will continue to the elevator. We are blowing through these levels. And we're going to the equalization room. Let's see, blah blah blah. Some numbers are bigger than other numbers. And sometimes they're the same. How can we know? Oh my. You're so funny. Look, we got comments. So, we need to get 2 things from the inbox. If they're equal, we'll put one of them in the outbox. Discard non-equal pairs. Repeat. Okay. That is easy enough. So, inbox. Copy that to 0. Get the next value from the inbox. And subtract 0. Now, we're going to use this nice jump of 0. And since we have comments, we might as well use them. If we're in this jump if 0 block, that means we're not equal. So if we're not equal, we can discard that value and go back to the beginning and try again. On the other hand, let's say we are equal. Well, we can just copy our value back from that 0 tile and outbox the result. And we'll jump back to the beginning so that we process all the inputs. And let's watch it work. So 2 and 5 are not equal. So we just jumped back to the beginning and got the next number. 6 and 6 are equal. So we're gonna outbox that. Doesn't matter if the value is positive or negative. It's only equal if we get a 0. So we have met our size challenge. And oh no, we didn't meet our steps challenge. Well, we're basically gonna use the same tactic that we've been using when we don't meet our steps challenge and try to get around it by skipping a jump. Be to 0. Sub-0. Jump if 0. Outbox the result. And if it's not equal, we'll jump all the way back to the beginning. Let's see if we can speed our process up by skipping a jump statement. Oh. Says we're gonna fail on some solutions. I think that is because we need to just jump to here. No, not that one. That one goes all the way to the top. It's this one. Can't get too clever. Oh no, wait. No, that's okay. Here's the problem. We skipped a step. Before we outbox, we have to copy from our 0 register. Alright. Let's watch it work. We definitely did not meet the size challenge this time. But we blew away the speed challenge. Beat it by a whole step so we can continue to the elevator. And we're in the maximization room. There's been a change of plans. We're not gonna treat all numbers equally anymore. We only want big numbers. So we're gonna grab 2 things from the input and put the bigger one in the outbox. Okay. We can do that. Inbox. Copy it to tile 0. Grab the second number from the inbox and subtract tile 0. Now, we're going to do something different depending on the result we get. Okay. So let's think about this. This is the second number. And if we get a negative here, then the second number is bigger. otherwise, the first number is bigger. Okay. So, let's say the second number is bigger. Well, we were holding the second number, and we subtracted the first number. So what we can do is if we add back the first number, now we're back to the second number, and we can outbox that. And that's a good little trick to avoid having to write the second number to a register, which would take extra steps. So if the second number is bigger and we outboxed it, then we're done. We can come back to the top. If the first number is bigger, we need to pick it back up from tile 0, outbox that result, and jump back up to the top. Let's see it work. 8, subtract 1, nope, it's negative. 8 is bigger, that gets outboxed. Negative 9, subtract negative 6. Negative 6 was bigger, that got outboxed. 4 and 4 are equal, so it doesn't matter which one we write to the outbox. Looks like the second number was always bigger for that particular set of inputs, so we didn't get to watch it work on. But we did not meet the size challenge. Let's see. We need to eliminate a step somewhere. Let's see. Where do we have an extra step? Oh, here's where. Instead of outboxing here, we can just point our jump to right before we outbox. And that's gonna eliminate a command from our program. And now we will indeed meet the size challenge. And we met the speed challenge with this program too, but you can see that our other program was actually a little faster, completing in only 32 steps instead of 34. So that's a good time to stop. Thanks for watching. This is Loxa Games.